Hi everyone, my name is Thomas Claudius Huber and welcome to my course WPF and MVVM Test-Driven Development of View Models. I am a Microsoft MVP for Windows development and I have a passion for user interfaces. When I build a WPF application, I usually apply the MVVM pattern. A big advantage of the MVVM pattern is that you can test the complete code of your view model with unit tests. This course is an introduction to test-driven development of view models. Test-driven development means that you write your unit test before you implement the actual logic. Some of the major topics that we will cover include creating unit tests in Visual Studio with XUnit, writing testable view models by abstracting away dependencies, mocking dependencies with the mock library, testing the view models of the friend storage application, and also testing dialog interactions in MVVM. By the end of the course, you will know how to develop your view models in a test-driven way to improve the quality and maintainability of your MVVM applications. For this course, no prior experience with unit testing and test-driven development is required. I hope you will join me on this journey to learn how to develop your view models in a test-driven way with the course WPF and MVVM Test-Driven Development of View Models at Pluralsight. Welcome to the introduction module of the course WPF and MVVM Test-Driven Development of View Models. My name is Thomas Claudius Huber and I'll show you in this course how to implement your view models in a test-driven way. Test-driven development means in simple words that you write your unit test before you implement the actual logic. Besides test-driven development and writing unit tests, you also learn in this course a lot about MVVM in general, about dependency injection with AutoFac, about mocking with the mock framework, and much more. When you hear about unit testing and test-driven development, you might ask yourself the question, why should you care about tests? I don't know much about you, as this course just started, but maybe you belong to the developers who are saying that they don't have enough time to write tests. Maybe you even say that you already know how to implement your logic, so why should you write a test for it? You should care about tests because code without tests is bad code. This statement was made by Michael Feathers, who wrote the book Working Effectively with Legacy Code. Michael says that it doesn't matter how well written your code is. It can be very nice, object-oriented and encapsulated. But as long as you don't have tests, it's bad code. If you have tests, you can change the behavior of your code very quickly and verifiably. Because after a change, you can just run your tests on the code to see if you haven't broken existing logic. Without tests, you never know if you made the code better or worse. And that's the reason why code without tests is bad. In this course, we don't want to write bad code. We want to write good code. And that's why we build our view models in a test-driven way. Alright, so let's start by having a look at the course outline. The course WPF and MVVM Test-Driven Development of View Models consists of 5 modules. The introduction module is the one you are currently watching. In this module you learn about MVVM, unit testing and the friend storage application. The friend storage application is the sample application we use throughout this course. After this course outline, we will have a quick look at the module outline of this introduction module. In Module 2, you will learn about unit testing and test-driven development. We will write the first unit tests for the view models of the friend storage application. Then we will reach the point where we want to load data in the view model, but we don't know how to test it. And this leads to Module 3. In Module 3, you learn how to write testable view models by abstracting away the dependencies from the view model. Such a dependency is, for example, the loading of data. Instead of writing this code in the view model, we will create an interface, for example, iDataProvider, that has a load method. Then we will create on the view model a constructor parameter of type iDataProvider. At runtime, we can pass into the view model's constructor an iDataProvider implementation that is accessing a real database. And for our unit test, we just create a specific iDataProvider implementation that just returns some test data. Writing this test-specific implementation of the iDataProvider consumes a bit of time, especially if you have more than this dependency. And that's why you learn in Module 4 about the mock framework that allows you to mock the dependencies on the fly. And then you have really an effective way to unit test your view models. With the knowledge of the first 4 modules of this course, we will continue and finish the friend storage application. So in Module 5, we will implement the loading of friends in a tab. In Module 6, we will implement the logic to close tabs and to save a friend. In Module 7, we implement the logic to add a new friend in the friend storage application. And in Module 8, we will implement the logic to delete an existing friend. We will do all of that stuff in a test-driven way, so we will write a lot of unit tests. When the user deletes a friend, we want to display a dialog with the question, do you really want to delete the friend? And the user can select yes or no. How to display such a dialog is part of Module 9, Interacting with Dialogs in MVVM. In this module, you will learn how to abstract away dialogs from your view model so that they will not block your unit tests. Alright, now let's have a look at the module outline of this introduction module. In this introduction module, I will show you the basics about the MVVM pattern before we take a look at the advantages of MVVM and unit testing. I told you already a bit why you should care about tests, but let's look a bit more detailed at the advantages of writing unit tests. Finally, you'll learn in this introduction module about the friend storage application. The friend storage application is the application for which we build the view models throughout this course. Alright, so let's start with a look at the MVVM pattern. The model view model pattern, or short MVVM, is a state-of-the-art pattern for WPF applications. With MVVM, you have a model which can be, for example, a friend class with the properties first name and last name. Then you have a view model, which is another class that is using the model. The view model has public properties that contain data. For example, the view model could have the properties first name and last name that are accessing the same properties of the underlying model behind the scenes. In addition, the view model could have more properties, like for example, a full name property. All the public properties in the view model are defined exactly how they are required by the view. The view is accessing the public properties by using data bindings. So for example, you can have a first name and a last name text box in the view, and both text boxes are bound to the properties first name and last name of the view model. To make the data binding working, the view model is assigned to the data context property of the view. That means every element in the view can bind to properties of the view model. Now in a real application, you don't only have data properties, you have also some actions that happen on the view. And these actions are exposed by the view model in the form of commands. So beside the public properties with data, the view model has public properties of type iCommand. And so the view is also binding to these properties. So for example, you have a Save button in the view, and that button is using the Save command property of the view model with a data binding. Okay, that's the MVVM pattern in short. We will see this in action when we look at the friend storage application and when we implement the view models. Now one thing I want to mention here. When you look at this graphic, you see that the view model is independent from the view. The view model only knows the model, but it does not know the view. And this leads to many advantages of the MVVM pattern. So let's look at some of these advantages. Building your WPF application with MVVM gives you some advantages. One of the advantages of MVVM is maintainability. As the view logic is implemented in the view model and so separated from the view, you can really focus on that logic when you build your view model. You don't have to care about controls, layout, and other view-related stuff. On the other side, when you build the view, you don't have to care about the logic because that is implemented in the view model. So for example, if the view binds to a Save command property of the view model, the view has just to take care of the data binding. How the Save command works and how it is actually implemented is part of the view model. This separation between the view and the view model gives your application a really clean structure and makes it simple to maintain. Another great advantage of MVVM is testability. As the view model is completely UI independent, it is really great to be unit tested. In the view model, you don't have any code with controls and layout and other view-related stuff. You have just a class with public properties and logic. So this makes it very good to unit test. Besides maintainability and testability, there are other advantages of MVVM. One advantage worth to mention here is the improved designer-developer workflow. With MVVM, you can provide a design-specific view model at design time for the view. So a person who is creating the UI will actually see the data of that design time view model, and he can create a nice looking user interface. Okay, in this course we will focus on the testability part. We will build our view models in a test-driven way. So let's look at the advantages of writing unit tests for your code. Writing unit tests for your code has some advantages. You can, for example, make huge code changes without breaking existing functionality. After your changes, you just run the unit tests, and if all tests are green, you know that the logic still works as before. Another advantage of unit testing is also that you get a great documentation. Well-written unit tests allow other developers to look at the tests to understand the implementation. Another advantage is that unit tests can improve the design of your code. This is especially true if you write the unit test before you do the actual implementation. And that's exactly what we do in this course by using the approach of test-driven development. Another advantage of unit testing is that writing a test makes you think harder about the problem. And this advantage is especially true with test-driven development when you write your test before you implement the actual logic. Alright, there are also more advantages of unit testing. I just gave you my 4 favorites. Now before we start with unit testing and test-driven development, let's take a look at the sample application that we use throughout this course.